Inverses. Let's talk about, get me set up here. So inverses, the big deal with inverses, the one thing you need to remember is y equals x. That's going to solve a majority of the problems that we're going to look at today. So the first Roman numeral is going to be graphs of inverses, and specifically drawing an inverse of a given graph. So to draw an inverse of a graph, let's first look at an example of a graph. Looks something like that. Looks kind of like the square root function, but it doesn't have to be. What we want, that in order to draw an inverse, you reflect f of x, so you reflect the given graph across y equals x. So y equals x, hopefully you know what that looks like. It's the line that looks like that, up 1 over 1 the whole way through. And so, see if I can find a different color here. So anything on the axis will be there. Any other points you can kind of reflect across. So we'll graph it kind of like that. So this was our original function. And this is our inverse function. We reflected it across y equals x. So that's first example. Another example of reflecting it across y equals x. Let's just draw a line, looks something like that. There's our original. Then we'll on this graph, we'll graph y equals x. And again, any point on y equals x will be on the inverse. So that point will be on there. And then you can just kind of pick some key points to reflect across. So that point become that point, and you kind of get the hang of it from there. That point should be over a little bit more like that. So there's our inverse of x. Again, reflected across y equals x to make the inverse. All right, Roman numeral 2 is the horizontal line test. Horizontal line test, it works like the vertical line test, but it determines if a function's inverse is also an inverse. So once you make the flip, is the new function also is the new relation also a function? Well, you determine that by the horizontal line test. So a couple of examples. This is really easy to tell because it works just like the vertical line test. So if I can draw a horizontal line test that crosses more than one place, well, that fails the horizontal line test. So this thing is a function, but its inverse is not a function because of the horizontal line test. So the horizontal line test is pretty easy, works just like the vertical line test. Let's do another example. So a little bit goofier graph, maybe has an asymptote to it. But any horizontal line I draw is only going to intersect the function one time. Again, that's the function. So its inverse is a function. Because the function's graph passes the horizontal line test. So that's pretty easy to do. Works just like the vertical line test, but it has a different conclusion. So vertical line test tells you if the original graph is a function. Horizontal line test tells you if the inverse is a function. All right, Roman numeral 3 of 4. Verifying. And verifying is kind of a fancy word for show or prove. Hope you like my Sonic cup here. Verify, show, prove, all mean the same thing. That two functions are inverses. So here's the rule. If f of x and g of x are inverses, then, you know what, let's write this instead of if then, let's make it an if and only if statement. F and x and g of x are inverses if and only if. That means it works both ways. If and only if f of g of x equals x and g of f of x equals x. The big deal is you have to test both of these things. You have to show that f of g of x is x and g of f of x equals x. If both of those things are true, then f and g are inverses. Or you could say it the other way around. If you know f and g are inverses, then those two statements have to be true. So let's try one. Let's try f of x equals 3x plus 4 and g of x equals 1/3 of x minus 4. Now we should be suspicious that this is going to work because we got times 3 and plus 4, and over here we got minus 4 and divided by 3. So there is something about those being opposites or inverses, but just looking at them isn't enough. We have to show f of g of x. So f of 1/3 x minus 4. So we grab the f function and we're going to plug in place of x, we're going to plug in all of this. 1/3 of x minus 4. And then plus 4. Okay, so now we've got a lot of algebra to do here. I could distribute the 1/3 first, or I could multiply the 3 and the 1/3 first. It doesn't matter. It would be easier if I did the 3 and the 1/3 first, but most people are probably going to distribute the 1/3 first. So I'll do that. Then when I distribute the 3 and the thirds cancel out, and I've got x minus 4 plus 4. So that equals x. So we're halfway there. F of g of x equals x. Next, let's try g of f of x. And by the way, when it says verify, it means it's going to work. You just have to show the algebra to get there. So g of 3x plus 4. So I go to the g function, and in place of x, I put 3x plus 4. And then the g function has the 1/3 and the minus 4 already there. Well, let's clean up the inside. So 1/3 times 3x. 1/3 of 3x would just be x, which is what we want. So we've shown that f and g are inverses of each other. In fact, we should say that. Therefore, f and g are inverses. So you can see it. And the video stopped. Oh, there it is. F and G are inverses. So we've done several F of G, G of F things. You've seen that several times. I'll do another one really quickly. Let's let f of x equal cube root times x minus 2, and g of x equal 1/2 x cubed plus 2. And I want to show that those are inverses of each other. So f of g of x means f of 1/2 x cubed plus 2, because I know what g is, so I plug g in. Now I'm going to look at the f function, and in place of x, I'm going to put all of this stuff, because that's what g is. That's now the input to the f function. Two times all that minus 2. So let's see what we've got here. Oh, I know what I did wrong. That 2 needs to go out front like that. There we go. So cube root 2 times the plus 2 and minus 2 will cancel each other out. I mean, these things always work like this. The 2 and the 1/2 cancel each other out, and the cube root of x cubed is x. So we're good on that one. Then we'd have to show the other one, g of f of x. So g of cube root of 2 times x minus 2. So we go to the g function. There's another way to try to keep straight of what's going on. I wrote the g function without the input. Well, but I want my input to be this complicated cube root of 2 times x minus 2, like that. So if I cube the cube root, that cancels each other out, and that leaves me with 2 times x minus 2. The 1/2 and the 2 cancel each other out, and then x minus 2 plus 2 gives me x. So again, g of f, f of g, you got to show both of them in order to prove that they are inverses. All right, lastly is finding an inverse. Well, finding an inverse, we go back to Roman numeral 1, where we verified or we checked a graph of an inverse by reflecting it across y equals x. To find an inverse, we're just going to switch x and y. So whoever's x becomes y, whoever y becomes x. So switch x and y, and then solve for y. So some of this, that part's easy. The hard part of this is the algebra for some people. So y equals 4x cubed plus 7. Well, step 1's easy. X equals 4y cubed plus 7. Like all I did was replace x with y and y with x. JT, can you get my phone charger from downstairs? In the kitchen. Sorry about that. But then I have to solve for y. So here's my new y. So x minus 7 equals 4y cubed. I'll divide both sides by 4. Y cubed equals x minus 7 over 4. And then cube root both sides. So there is my inverse. And if I really want to be fancy, I'll use inverse function notation like that.
Is this it?
Let's try another one of those. Let's do one that's really going to test our algebra skills here. So number 2, y equals, actually let's start with f of x equals, which we know means the same thing as y. F of x equals 4 plus 3 over 9 minus 2x. So that means y equals 4 plus 3 over 9 minus. All right, first step's the easiest one. Replace y with x, and x with y. Now we've got an algebra problem on our hand because we've got to solve for this thing right there. So we've got a lot of rearranging to do in order to get y
Zoom meeting
by itself.
You want a Zoom meeting?
I'm on a Zoom meeting, JT. So first thing we'll do is move that 4 over. So it's just going to be peeling it away until we get y by itself. There's no there's no magic to it. So x minus 4 equals 3 over 9 minus 2y. I think what most people would choose to do from here is cross multiply, maybe, because you got to get that y out of the bottom. So I'm going to, let's see, 9 minus 2y times x minus 4 equals 3. That's an okay step, but I still want to get y by itself. So I'm going to put the x minus 4 underneath the 3, like that. And now I'm getting close. Now I'm getting close. Subtract y over. And we're not too worried, excuse me, subtract the 9 over. We're not worried about common denominators or anything like that. We just want to get y by itself. And so even though this is getting messy on the right, to get y by itself, if I would multiply both sides by -1/2, y equals -1/2 times everything that's in parentheses there, 3 over x minus 4 minus 9. That's a ton of algebra steps. None of them beyond algebra 1, but that's just a lot of steps that you're going to have to be careful with and make sure that you're good with. That's what we do in pre-cal. We do a lot of firming up our algebra so that when you get to calculus, you can learn calculus without algebra getting in your way. And so this is one of those places where we check and see if our algebra is where it needs to be. All right, let's do one more. This one's not as bad as that last one, but something strange happens. Let's say g of x equals 5x squared. So y equals 5x squared, which means x equals 5y squared. Again, there's the function. And then we switch to the inverse by just replacing y with x and x with y. Now we're going to solve for y. So y squared equals x over 5. Square root both sides, but here's the big deal with this one. When you square root both sides, you've got to remember to put the plus or minus on there. And that's a problem because if you put plus or minus on there, you're no longer a function. We talked about this before. When that happens, that means this is not a function. So the inverse is not a function. The original was a function, but the inverse is not a function. In fact, if we go back to this original, I don't know exactly what that looks like, but it's a steep parabola, which would not pass the horizontal line test. And if it doesn't pass the horizontal line test, that means the inverse is not a function. So it has an inverse, but the inverse is not a function because it had that, basically because it had an x squared. We've run into that before. So when you get to a plus or minus situation, it's not a function. Maybe we could have told that from the horizontal line test if we had thought about it. All right, the assignment today is worksheet 7. There we go, worksheet 7. And I think I'm back on now. Answers are posted, and eventually there'll be a video of me working some of the answers as well. Whoops, I don't know if that's recording or not. Anyway, there's answers posted. Good luck. We'll get through this.